Guys, so welcome back. This is a portfolio risk and return. This is the second part in your CFA Level 1 curriculum. So portfolio risk and return. So basically we're just building upon the ideas that we have already taken in the first part of the portfolio risk and return. So let me just recap some of the formulas that we have taken earlier, because we're going to see those formulas again in this chapter, and I just want to make sure that you guys get a grasp and get a good grasp on the idea that on the framework that we are working with. So basically what we said last lecture is that if we have a risky portfolio, right? Risky portfolio, and let's call this portfolio A. Okay, this risky portfolio is comprised of risky securities, right? So it does not include any risk-free asset. And let's say that we have chosen this risky portfolio to be the optimal risky portfolio in the market, right? The optimal. This is, in our opinion, as investors, in our opinion, this is the optimal risky portfolio. Now remember, different investors have different expectations, so they have different beliefs about the optimal, about what would be the optimal risky portfolio, and therefore they have different expectations, right? So if we all have the same expectations with regard to this risky portfolio, with regard to this optimal risky portfolio, to be more accurate, then this then it would be called the market optimal risky portfolio. Now, for now, we're just assuming that as investors, for each and every one of us, we've got an optimal risky portfolio. Let's call it A, and we've got a risk-free asset, which is B. Okay, and basically what we're trying to do here is that we're trying to say that if we want to combine this risky portfolio, this optimal risky portfolio, with a risk-free asset, the expected return on the new portfolio, which combines those two, is the weighted average of the expected returns of those assets, right? So it is weight A multiplied by expected return A plus weight B, and we put here risk-free because we cannot put the expected return, otherwise it would be risk-free, right? So we put the risk-free rate of return here because there is basically no expectation about the risk-free rate. There is certainty about this rate of return, and thus we put risk-free directly into we plug it in the formula directly. Okay, now from algebra, this is the 7th grade, I believe. We took that weight A plus weight B. If we only have those two in the portfolio, they must equal to 1, right? They must equal to 1. So we can state that weight B is equal to 1 minus weight A, right? Alright, so let's substitute this weight B by this expression. So what we get is weight A, expected return A, nothing changes here, plus 1 minus weight A multiplied by the risk-free. Okay, now next step is that we want to multiply this risk-free by 1 minus weight A. So what you get is, you get plus risk-free minus weight A, and here risk-free. Okay, now notice guys, we've got two weight A here, right? We've got it in this expression and in this expression. So what I can do is I can isolate this weight A from this formula and write the formula as follows. I can say the expected return on the portfolio becomes weight A multiplied by expected return A minus the risk-free rate. So basically what I'm saying here is weight A multiplied by expected return A is the same as this expression, right? And weight A multiplied by minus risk-free is minus this whole expression. So we're left with the risk-free rate. And I like to put this risk-free at the beginning of the formula, so just rearranging, nothing fishy here. I just want to put this risk-free at the beginning of the formula because it is the intercept of this linear equation. And let's put this here, right, at the latter part of the formula. So expected return A minus the risk-free. Okay? Now, let us pause here for a second. Let's call this, if you will, equation 1, right? Let's call it equation 1. And here, we are finished with the expected return formula. Okay, we're finished with this formula. We just want to improve upon it later. You'll see how. Okay, now let's talk about the variance of the portfolio. The variance of this new portfolio is the weight 1, weight A squared multiplied by variance of A plus weight B squared multiplied by variance of B plus 2 weight A, weight B, and covariance between A and B. Okay, so B is basically the risk-free asset, right? And the risk of the risk-free asset is basically 0. Okay, it is 0. So this expression, it cancels out from the variance of the new portfolio. And we know that, we said it in the previous lecture, that the correlation of the risk-free asset with any other asset is 0. So this expression, the correlation makes the covariance. If the correlation is 0, then the covariance is 0. So this expression cancels out. Now, when I say if the correlation is 0, then the covariance is 0. Basically, what I'm trying to say here is they are both tied into this formula. Correlation equals the covariance between A and B divided by sigma A multiplied by sigma B. Okay? Sigma B is 0, right? This is 0. 0 multiplied by whatever is 0. So the variance is 0. Correlation, well, it is 0. Okay? So what we're left here with is only the first expression, which is weight A squared multiplied by variance of A. Okay, this is the variance of the new portfolio. So the sigma of the new portfolio is weight A multiplied by sigma A. Okay, now what I want to do, and let's write it in black right here, is I want to isolate this weight A from this formula. So weight A is now sigma portfolio divided by sigma A. Okay, and then I want to insert this this equation into instead of, I want to substitute it with weight A right over here. Okay, so we're left with now the